And it's going to be 0, I believe. Now the error protocol, I want to get rid of these now. It's bothering me. Dude. Yeah, let me look that up. The error protocol. So if you run a Haskell function and you return values to Lua, then you have to tell the Lua interpreter how many results to expect, because you're going to be pushing those return values onto the stack in the interpreter. And so the interpreter will then pop those values off the stack and then return them to the user. But in the case of an error, okay, to actually indicate errors, we have to use this handy dandy wrapper function, result of error. Okay, so we push a string onto the stack and then we push that into error. Okay. So let's use that. Then on 107, there we go. Okay, so that's good. I'll do that here as well because that's going to come up again, but I just have a quick little error to deal with. The string here. Oh, okay. I gotta put like com ID like that. Okay. Count ID. Yeah, it's because query name. Okay, so we have like a slight syntax mihu. Probably because of the way we're using fmap. Maybe. Maybe if I put that here. There. No. We're just going to go avatars there. We'll just put list of maybe avatars. Oh, I gotta put the connection in. I'm missing an argument. And in the wrong connection type there, perhaps. Yes. We want the DB connection. Okay, yeah, that's getting a little close to confusing because I'm mixing up DB handles and as connections. And we also have connections as in our connections, the server's connections. So many connections, so little time. Right, so we gotta get the DB handle and all that stuff. And that's not what I called it. I called it DB handle, not database handle. Close enough. There we go. Okay, and so this type error here is because there's no instance of toField for a Lua integer. So I can unwrap that to a Haskell integer, I believe, that does have that instance. Here. There, yep. Now we're back down here, so we have this hole. Where, once we get the avatar, oh, right, we need to update the state of the connections map. So that comes from STM containers. In fact, I think I have an example of that code here. List avatars, no, set avatar, no, it's not in here. It's in command. That's the parsers. No, maybe it's in server itself. Yeah, server, a high level thing. Handle login. Yep, this. So we create a focus and we give it to smap, which does the update for us. We just need to change this function here. Update the connection state, and we'll pass in the avatar. And update connection state. We need to bring focus into scope. Okay, and the type, it's avatar A to A, which is going to be it's going to be our thing connection. I believe. Connection to connection. Connections map. Okay, that has to get. We have to get that as well. Key almost. Okay, let's put the hole in. Get the type error back. Then all we want to do for the update connection state is to return the connection such that the connection avatar ID is just the avatar ID. And that's that. Okay, so let's run the server. And now in this session, if I press like choose one, it should work. I don't think we'll get a message anymore, so I think I removed that. And everything should be copacetti. I could probably write something to make sure that we know that we're hitting it right. But in the error case now, right, I should be able to give a ridiculous choice, give a bad ID, and we get an error. So let's try that. Let's see what happens there. So I'm going to log in, Bakamud there, boom, boom. I'm going to choose 1, 2, 3. Not a valid index, right? We had nothing. Now we're not doing any error checking on the Lua side, but we could. Now if I choose 1, then we get the you picked one, and everything's good, as before. Right, and so now in the server state, the connection should have that avatar's ID associated with the connection. So now we can continue on with the story, where now that the connection has the avatar ID, we should be able to like update the ticks on the simulation and send passive output to that affects that avatar to the associated connection. Right, and then send that update to, which ultimately sends the update to the user. And we should be able to implement the rest of our game commands in our code, in Haskell, and in the game developer side, and like update those things. So like if a mob attacks your avatar, you'll get like, you've been attacked message, or you've been hit and damaged by such and such mob, or whatever damage, however the game developer wants to implement that. All those sorts of things. Okay. So that's a pretty good step there. Let's cradle commit for that. Or let's maybe look at a bit of the code, maybe so we can clean up some things. And for some reason my ticks are got out of spawn. There we go. Okay, I'll create a little work in progress commit for it. Implement set avatar Lua API function. Okay, let's see if we can make this a little cleaner. I think the first thing might be to create some helper functions for getting these Lua arguments and turning them into errors if they are not present. And that way we could turn this into just connection ID and avatar ID. So that's going to have to be in the Haskell function E mono, which is a type alias for Lua E something something something. Get argument. That's going to have to take probably an index, looks like. Nth bottom this, nth bottom that. And we don't know, the other thing that's going to be a little bit tricky about that is that the two integer and which function to use. So I'm thinking maybe we should take this whole function as an argument in our type, which is, let me actually just look that up interactively here. Import, is it Lua? hslua.core. And the function type of two integer. Okay, so this type is what I'll pass in here. Right, and then I'm going to return our Haskell function E. So I think the type constraint on E though is Lua error. And that should be good to go. GHCID, build it up. Builder going. Oh, what happened here? Oh, oops. What did I do? Oh, I accidentally removed some code, didn't I? Cool. Oopsie daisy. Anyway, stack index is Lua.stack index. Because these are all qualified imports. Lua.e. Lua.integer. Now we need to make a little bit more, not Lua.integer specifically, but some A. And what's the type alias there? Actually, I need to know. It is Lua enum results. We don't actually need, no, that's not the type error alias we want. It's gonna be Lua E and A. Okay, so we'll call the argument like get from stack, or just from stack. Lua stack. Yeah, that's probably good. Hey Twitch TD, welcome back to the stream. How's it going? How's it hanging? Okay, so let's get our maybe arg by calling from Lua stack. Oh, we'd have to give the argument for the Lua stack index. So let's take that as an argument. Stack index. Oh, yeah. Good. You got back into Haskell, Twitch TD. Good for you. That's awesome. What are you working on? Is it a personal project, like for fun? Or is it more like a work thing? Working through unsafeperform.retroclash. Interesting. Let me check that out. Let us check this out. Unsafeperform.io. Retro computing with Clash. No way. Yes, Clash is awesome. Okay. So this particular book, Retro Computing with Clash, takes the experienced Haskell programmer on a journey into the world of hardware design on Clash. Our approach is based on using Haskell to its fullest potential, using abstractions like monads and lenses, and building a library of reusable components. That wouldn't put the fun in functional programming, so we put these components to good use in implementing various retro computing devices. A pocket calculator, Pong, a simple but Turing-complete computer that uses BF as its machine code, an implementation of Chip 8. I recently did an implementation of Chip 8. Well, not the hardware. An emulator. It would be interesting if they, like, this Chip 8 computer specification. Here's, like, the actual hardware for it, which was the Cosmac VIP, I believe, is the first one. An Intel 8080 CPU, Space Invaders arcade machine. Dude, that is cool. I want to do this now. Yeah, I did the Niantic Tetris course a bunch of years ago. Maybe like two or 3 years ago. Which is kind of a similar-ish thing. Only they're using straight Verilog. There's like a part 1 and a part 2 of the course. And part 1 has you design the hardware. And part 2 has you design the software. So like actually writing a compiler for a language that runs on the hardware. I can compile the machine down to machine language for the hardware. And pretty cool. I did the part 2 in Haskell. But part 1 was in Verilog. It'd be kind of neat to be able to do that fully in Haskell, like 100%. That'd be super sweet. Cool. Thanks for sharing. That's awesome. Anyways, back to it. So if we have the argument, then we actually have the argument. Yeah, we would just return that. Otherwise, we're gonna Lua output string. Missing argument. A generic error, I guess. Maybe with a more information, we could fill that in with something. Yeah, we can convert the stack index to something that could say like missing second argument, missing first argument. But then we just lua.error. Oh, sorry, not push string, push string. Right, Lua error doesn't work here. That's not going to be useful. How come we need to return num results, though? Oh, is that because of the type of lua.error? Probably. Yeah. We'll throw error as exception. Oh, into a Haskell exception throws. That's not what we want. You can throw a type mismatch error, but that's not quite right. Maybe there's a helper function for this already. Okay, well, fail Lua, yeah. Maybe. There's an exception. I don't know if that's quite it, actually. Or Lua exception. That's for Lua error, E. Let's see. Let's look at this one. Fail the... Yeah. Don't think that's what we want. Maybe though. Maybe an exception in the Lua monad doesn't necessarily mean that it's going to error out on our side. So we could, instead of this, fail Lua. key argument. Okay, that one's all good now. At least, hopefully. Okay, so let's use it for one of some of our arguments here. So I should be able to get just the raw avatar ID with get argument. And then the connection ID. Then we don't have to have this top level unwrapping. So we can get rid of a layer of nesting. Which we'll put this up here. Let's put this here. We have to readjust everything else here. Okay, and let's see. We're getting an error here on line 92. Oh, the stack index. Yeah, we gotta pass this as individual arguments. And I just need some constraint here. Great, cool. And then avatar ID here. Oh, sweet. That's a little nicer. Got rid of one layer of nesting. Let's go, keep going. Okay, the next layer of nesting comes up because we need to validate the connection ID. Right, and we also need to validate the count ID. Which we also just turned into errors in both cases if they're invalid. So we could do a similar kind of approach up here, or we could get the connection with a function like valid connection. Yeah, maybe from the server state. All right, it's not in scope, but it kind of, GHC is giving us like kind of the type, the shape it should have. All right, server state. That's got to be a Lua E E2 connection. Oh, sorry. There we go. Okay, so we just got to fill in this hole. And we know how to do that, right? To get rid of that arrow, we got to get the argument there. Okay, now we just have to return a Lua E, this Lua evaluation with the connection. All right, so all that code, we know how to do that. In fact, we're going to need the raw connection ID from the arguments, so... Or maybe we can just put it in as constructed before passing it in. Integral raw connection ID. So we take this code here, here, and here. All right, we have server state and scope, so that should work. Connection ID. We actually create the connection ID from the raw connection ID. But this is going to have the connection ID. So we don't need that. I'll put the hole back in there. Okay. And there we go. So this hole is pretty straightforward. If we have the connection, then we just pure connection. Okay, except something wants us number results here. Okay, once again, I think we got to use the Lua fail Lua approach. And then we need the Lua error E constraint. Yeah, let's just clean up the code there a little bit. Okay, back up here. So we can get rid of that, we can get rid of that. We can get rid of this nesting here, and that error case, and that. And then we can bring this all over. 1, 2, 3, 4, yeah. Nah. That. There's connection ID used again. Down here. To update it, so let's bring that back in scope by binding this. Get rid of the parentheses. Now we can add that there. Okay, I think that's rid of another level of nesting, making this code a little nicer. Okay, connection validation. Let's see if we can do anything with that. So this is invalid connection, as in, like, we shouldn't even be able to reach this if we're getting to this point. And once we have the account ID, then we do our validation. We could probably do a similar approach. In order for that, we're going to have to pass in the server state the connection and the account ID, or so the avatar ID. Which we just use the raw avatar ID. So I'm going to make avatar ID like that. Okay, nanoscope doesn't exist, so let's go make that happen. All right. We're going to need Lua error. E constraint, server state, connection, an avatar ID, and then we can do a Lua E avatar. Okay, cool. So this error here is because I'm calling the avatar ID isn't existent yet, so let's create that. What did I do? Okay, cool. So if we can invent it, if this function exists and works, which it doesn't yet, but if it did, we should be able to get rid of that level of nesting. So let's put our hole here. Let's get rid of those arrows and just go through the motions. Clock connection, avatar ID. There we go. No more arrows in the type hole. So then we'll go do, put a hole here, and that's because we're going to go grab that code, look up the avatars and all that stuff. Sorry. Look up the avatar that we want. We're also going to need the DB handle to do that. Put this here. Our hole there. And change this to DB connection. Yeah, I know account ID isn't in scope. Oh wait, we're gonna need that, yeah. Okay, so we're gonna add that as an argument. And where we call it is also gonna be updated. Which doesn't exist yet, because that's actually one level of scoping that we have here. Yeah. Actually, maybe we don't need this. No, hang on. Let's get rid of valid avatar here. Back up a little bit. It's this connection account ID. So that... What would we call that, though? So we want to remove this level of nesting here on the connection account ID. It's not necessarily... If we hit this as an error, it literally is because we messed something up. All right, and so the game programmer implementing this stuff in Lua, if they try to catch this as an exception on the Lua side, it's not going to make a whole lot of sense to them. Or at least it shouldn't. Because we can't really... Like, we could say, like, this should never happen, but it's like... What? You know? Like, they can't do anything literally about it. They don't know. So I almost want to, like, assert that it's true. Like, throw a runtime error. So I'm going to call it, like, require account ID from the connection. Okay, let's try to implement that. Lua.lua error e connection Lua.lua e and we're going to return an account ID. So in the nothing case, otherwise, Oh, sorry, as a function connection. There we go. There. Yeah, so assuming that works, we can get rid of this, and we can bump this up. There. And that should just compile, so that's another level of nesting gone. And then the account stuff, this is fine. I don't think we need to do that. It's special to this function so far, and yeah, this is an acceptable level of nesting here. Okay, so let's just make sure that this all works, of course. And we don't get any exceptions when we run this, and run the choose command that uses this function. So log in, Bakamud, good. Choose one, and as before, you picked one just fine and no exceptions. Okay, now if we try and choose again though, we should still get one. It's just going to set it again. Alright, so we're probably going to need to implement some kind of API for the game programmer to like check the state of the session, just so that if they want to, they could say like, you know, you've already connected this character, or they can say like, okay, now I'm connecting you as this character and changing your character to this, or whatever the game logic should be for the server, right? But if I choose 1, 2, 3, that should be out of scope. Picked 1, 2, 3, but that should actually maybe not work. So we've got a couple of things still to implement, but yeah. That's not going to hit our Haskell code, actually, the 1, 2, 3 stuff. That's going to be protected from the Lua side, so... let's mess up our Lua code and see if we can get it to hit some of these situations. So if we just remove this, restart the server. Now if I choose 1, 2, 3, what do we get? We still get you picked 1, 2, 3. Okay, so no exceptions. Oh, because we're going to call setAvatar for all the valid IDs that are in the database, so of course, let's just hardcode something silly. Get a connection, log in, there, and no matter what we choose now. Okay, now we get a call stack error here. Okay. Calling Lua code failed. Okay, and that, I think, when we get an exception, like, I think that's a runtime exception, like a full IO exception, so that might have killed the thread there. And the server will stop responding in that case. Like part of the server's still up, just that thread handling command stuff is dead. Okay, that's no good. So if I catch this on the Lua side, it should be good. So I'm going to create a little mini commit for this, a work in progress commit for this code at the moment, but I wanted to try out Lua exception handling, and if we do that, can we avoid throwing that exception there? So refactor, set avatar, and then just want to mess around with this a little bit here. So try. Catch. Okay, so for many applications, you do not need to do any error handling in Lua. Usually the application program does the handling. Well, that's a hint. Maybe we should be doing the handling. All Lua activities start from a call by the application, usually asking Lua to run a chunk. If there's any error, this call returns an error code and the application can take appropriate actions. In the case of the standalone interpreter, its main loop just prints the error message, continues showing the prompt and running commands. If you need to handle errors in Lua, you should use the pcall function, protected call, to encapsulate your code. Suppose you want to run a piece of Lua code and try to catch any error raised while running that code. Your first step is to encapsulate that piece of code in a function. Let's call it foo. Function foo. If unexpected condition, then error, and print something, potential error. A may not be a table. Okay, so this is the buggy function, foo. Then you call foo with pcall. Pcall foo, then no errors while running foo. Otherwise, foo raised an error, take appropriate actions. Of course, you can call pcall with anonymous function. The pcall function is protect mode, so it catches any errors while function is running. Okay. Despite its name, the error message does not have to be a string. Any Lua value you pass to error will be returned by pcall. Okay. So if the Lua code calls Haskell, and we use this error, stuff that we've been writing to like Lua fail Lua, missing an argument, or in this case, I think we're actually hitting more up here, where I push string and then call Lua.error. So I mean on the Lua side, if I call pcall set avatar, that we could do, we would get the error string back maybe. So any Lua value passed to error will be returned by pcall. I wonder if that's the same for Haskell functions. So if I call local error equals pcall set avatar, let's print it out. Does this work? So we reconnect. We log in. And whatever we choose, because we're implementing buggy code. Okay, we still get call stack. The code failed. Okay. I think we should take that hint. Handle it on our side. So it doesn't seem like that's going to work for us. So anytime Lua code calls our Haskell functions, if we throw some kind of exception, then we have to handle that situation on our side and the Haskell server, like on the server side and the Haskell code. That's going to be, I wonder how that's going to turn out. So the game program, we should assume that the game programmer can just call this code and never check the results. Whether set avatar ever worked, or whether this is an invalid ID, or anything of the sort. We just do it. And then maybe we log it on the server logs that like, hey, you tried, and you failed. So maybe there's something on the Haskell side that we can use to, like, in this left case, like I'm just printing out like the Lua code failed, but like maybe we can get the error maybe and log it. Do I need to make it part of this change? Well, we're almost out of time for the stream, so let's just format this commit and push it up, and we'll call it a night there. And maybe we'll start doing a little bit more investigation down that road, and maybe error handling in general next week. Cool. Cool. So let's do a refactor interactively. Let's squash that one and reword that one. And then we'll call it implement set avatar Lua API function. Allows the game programmer to set the avatar for the connected session. And there we go. So, thanks for watching and hanging out with me. If this is your first time watching this stream, that's awesome. Welcome. All the code you've seen tonight is for a project called Bakamud. It's hosted up on GitHub for now. I'm Agent Ultra, and I'm also Agent Ultra on GitHub and a bunch of other places, like agentultra.com, my website. So I'll paste the link there in the chat for you. Boom. And you can follow along with the development of the project there. A basic mud server, or maybe not so basic. I don't know. But thanks for watching. Thanks Twitch TD and everyone else. It's been a slice. So you can follow me there. You can follow me on GitHub. You can also follow me on the Fediverse. I'm on the Mastodon. I'm on Mastodon on the types.pl server at Agent Ultra there. You can also go to agentultra.com and find all the links to all my stuff, other stuff like my YouTube channel where I back up the VODs for this stream. You can also go to the link above my head. That's to declarative.tv, where there are other streamers who are doing things like Haskell and doing streams in Elixir and Erlang and other declarative style programming languages that are looking for an audience. And if you have more attention to give, I'm sure they would appreciate it. And maybe you can find something cool there too. There's also a Discord server on that site that has a channel for this stream. So if you want to ask questions or hang out or talk about your projects, everybody there is a hacker and is super happy and supportive and wants to learn about what you're up to as well. So come hang out with us there. And that's all I got for this week. I usually do these streams at about 10 after 8 in the Eastern Standard Time Zone. And if you follow me here and you have your notifications set up, if I do other streams, which I sometimes do during the week randomly, you'll get notified when I go online. So maybe consider doing that. And like and subscribe and all that stuff on YouTube. Take care out there. May all your monads be free and your types always check. And happy hacking. Peace out.